All right, stats class. This is Mrs. Leong, and I'm going to go over lesson 6.7, talking about simulations. All right, so you guys have all probably heard of this word simulation. I think one of the most common ones is like a flight simulation, where people who are learning how to fly planes, they use a flight simulator to have the same kind of feeling and same situation as a real plane, but without the risk. So that's what we're going to be doing today. I'm going to teach you guys how to do a statistical simulation where we'll simulate a situation, but using numbers instead of the actual event or situation happening. All right, so a simulation provides a means of estimating probabilities when we are just unable to determine them analytically, or it is impractical to estimate them by observation. Okay, so let me show you the steps first, and then I'll give you guys an example. All right, so the first step you want to do is to identify the event to be repeated. All right, so you want to kind of understand the situation and understand what you need to set to be considered a trial. All right, and number two, explain how you will simulate the trial. And how you explain it, a couple of things you want to keep note is that number one, you want to talk about how many digits at a time. And what I mean by that is you're going to have just a list of random numbers to use for your simulation. And you need to give the instruction of should you pick one digit at a time or two digits at a time, three digits at a time. So that's very important to say how many digits at a time we should pick. And this will make more sense, I think, once we get into an example. All right, the second thing is a stopping rule. You want to give a stopping rule. So you need to tell the person running the trial, this is when the trial ends. All right, number three, you want to ignore any repeats or not. That's important to tell also. Some situations you want to ignore any repeating numbers, and some situations you don't ignore repeating numbers. All right, so you want to specify that. And lastly, you want to think about the outcome. All right, so what is the outcome at the end of each trial? What are we looking at? Okay, so that's how you want to explain your simulation of trials. And I'll give you guys an acronym later on to help you remember these steps. All right, number three in the steps is you want to actually run your trials now that you know how to do them. Analyze the outcomes of each trial, and then state your conclusion in the context of the problem, as always. All right, let's see an example. So suppose we have couples who want children, were to continue having children until a boy was born. Okay. Would this change the proportion of boys in the population? All right, so this is our question. And obviously we can't do this practically, all right, or actually. We're not dictators of a country, so we cannot mandate couples who want children to keep having children until they get a boy, or once they have a boy, they have to stop having kids. So yes, this is why we need a simulation. All right, so to estimate the proportion of boys in the population, we need to think of a way to, yeah, to simulate the situation. So what I came up with was I am going to use single digit numbers. All right, so from 0 to 9. And I'm going to have the odd digits represent a boy and an even digit to represent a girl. And that works because every baby born has a 50-50 chance of being a boy or a girl. And in the same way, every single digit being picked has a 50-50 chance of being even or odd. All right, so that's why it simulates the situation. And then I'm going to select random digits from a digit table one at a time. And I'm going to stop once a boy is recorded. And that stops the trial. That's my stopping rule. All right, and then my outcome will be just how many boys, right? How many boys out of the total, what is the proportion of boys in the population once the trial is done, or once the trials are done? All right, we're gonna do many, many, many trials and see what happens to that population. Okay, so this is what a random digit table looks like. All right, this was pulled right from the back of your book. You can start at any row since it is random. So just picked row 6. So you can start at row 1. You can, pick your favorite number and start at that row. It's a random digit table, so you can start anywhere. All right, let's go ahead and run some trials. So remember, even digits will be girls and odd digits will be boys. And we're going to stop once a boy is picked. All right, we're going to stop that trial. Okay, so look at trial 1. I'm going to be at this top left-hand corner with the 0. So that is my first baby. And that baby turned out to be a girl because it's an even digit. So that trial keeps going. And then I have 9, which is a boy. So that is the end of that trial. Okay, once a boy is picked, the trial ends. And I show that using that vertical red line there. So draw a vertical line showing that that is the end of that trial. All right, so we have a girl and a boy. Next trial, I'm going to move to the 3. That's an odd digit, so that is a boy, and that ends the trial. The next trial, I got an even and an odd, so girl and a boy, and that ends that trial. Trial 4, once again, I get a girl first and then a boy, and that ends that trial. And the next trial starts with an odd, so that's a boy, and that ends that trial. All right, so it seems pretty even though the boys seem to be winning at this point. All right, let's go all the way up to trial 10. So trial 6, I get boy. Trial 7, boy. Trial 8, girl, girl, boy. Trial 9, girl, boy. And trial 10, girl, 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 boy, as I jump down the row. All right, so we're going to stop there. If we were to continue, that would be a better estimate, but we just don't have that time. So let's calculate what the proportion of boys is. So there's a total of 10 boys, all right, which makes sense, 10 trials. Each person has, or each couple has a boy. And there are a total of 22 children born. All right, so that ends up being kind of close to 0.5, actually. It specifically, or more exactly, it's 0.45. So it turns out, actually, that even with this rule, some people might think, oh man, there's going to be a lot more boys than in the population since every couple has to have a boy. But on the other end, every couple can only have one boy. They can have multiple girls. So it ends up kind of evening out and proportion ends up being close to 50%. All right, so we discovered what that proportion would be if this was an actual situation without actually having a country and being a dictator. All right, so the power of simulations. Okay, so now we just need to practice this. This takes a lot of practice to kind of get comfortable setting up these simulations. So for your description of how to do the simulation, I want you guys to use this acronym so you can make sure you have all the steps. So the first step that you want to describe is assigning digits. Okay, you want to assign your digits. So in the example that I just showed, I assigned evens to represent a girl and odds to represent boys. Okay. You don't always have to do even and odds. You can set, certain numbers like 0 through 3 to represent something, and then 4 to 9 to represent another thing if it's not that 50-50 percentage. All right, but you do want to say exactly what digits you will be assigning to represent what. All right, so that is the first thing. The next thing you want to talk about in your design is picking. Am I picking one digit or 2 digits at a time? All right, so like in the previous example, I said to specifically pick 1 digit at a time. There's some cases where you might need to pick 2 digits at a time. All right, so you have to kind of see the situation to decide which 1 or 2 digits to pick at a time. All right, and then the next step you want to explain is when to stop the trial. When to stop the trial. So in the example, we stopped the trial once a boy was picked or once a odd number was picked. So you want to specify, when does each trial end? All right, and then lastly, you want to say, count something for your outcome, right? It's like, what is the outcome after the trial is done? What do I want to know? So in the example, we counted how many boys out of the total number of kids. All right, so how many boys was kind of our outcome. All right, so APSC is your acronym. Okay, you can remember this in different ways. I've heard people use AP Stats class, all right, to remember APSC, AP Stats class. I've also heard, what was the other one? Oh, all poo smells crappy. All right, that was another fun one. All poo smells crappy, which with a newborn baby, I can definitely attest to. All right, so whatever acronym you want to use to remember APSC. Okay, let's go ahead and practice this with our handouts. And this one says, a large manufacturer of batteries knows that historically 10% of its batteries come off the production line defective, and the remaining 90% of batteries come off the production line in working condition. So we're going to conduct a simulation to estimate how many batteries the company needs to pull off the production line in order to be sure of ending up with 10 working batteries. All right, we want to describe how we will use a random number table to conduct this simulation. All right, so let's go through our acronym ASSIGN to describe how we're going to do our simulation. Okay, so APSC. The first one is assign. So let's go ahead and assign some digits to represent these batteries either being defective or non-defective. Since 10% of the batteries are going to be defective, I'm going to assign the digit 0. I'll just assign 0 to represent a defective battery. Okay. And I'm going to have 1 through 9 represent working batteries. All right, and this is to simulate the fact that 10% of the batteries are going to be defective. So when I'm picking digits from 0 to 9, there are 10 single digit numbers. So each single digit has a 10% chance of getting picked. So I'm going to set 0 to be defective, right? Giving it a 10% chance, and then 90% of the time it'll be working. All right, our next letter is pick. So as you can see, we're using single digits. So I'm going to pick one digit at a time when I'm going through the trial. All right, the next one is stop. So I stop the trial once 10 working batteries are picked. And at the end of each trial, I'm going to count how many batteries it took to get 10 working batteries. All right, so that is my simulation. All right, let's see how this plays out in our trials. All right, so let me go ahead and bring this down so I can see it while I'm working my trials. Okay, so show 3 trials by clearly labeling the random number table below. Specify the outcome of each trial. All right, so let's go ahead and mark this up now. So trial 1, I picked a 1, so that is 1 working battery so far. And then I hit a 0, and a 0 is a defective battery. Okay, so I'm going to put an X there to represent defective. Then I get another working battery, another working battery, another working battery, another working battery. Oops, got a defective one again. And then I have my 6th working battery, my 7th working battery, 8, 9, and then 10, which means I should stop the trial right here, vertical line, to show the end of that trial once I have 10 working batteries. All right, and then it says to specify the outcome. So our outcome, we said, count how many batteries it took to get 10 working batteries. So in this case, it took 12 batteries to get 10 working ones. All right, so let's do this a few more times. And next trial 2 down below, I have 1 working battery to start, then another, then another, then another, 5, 6, 7, 8, 9, and 10. All right, so I did not run into any defective batteries in that case or that trial. So it only took me 10 batteries to get 10 working ones. Okay, let's try it one more time with trial 3. And this one starts off with a bad one. So I got defective, not defective, not defective, not defective, not defective, and just continue. Got a defective one on that one until we get 10 good batteries. All right. So there we go. We have the end of our trial once we have 10 working batteries. So this time it took us 13 batteries to get 10 working ones. All right. So now let's go to our final conclusion here. And oops, let me clear this out. All right, so this last part, it says state our conclusion. Okay, let me see if I can bring this up. And let me bring these up. All right, so state your conclusion. Basically, on average would be a good conclusion, right? To say on average, it took us, and just average out 12 plus 10 plus 13 divided by 3. So I'll say according to the simulation, right? Because that's important to know that we didn't actually do it. We just did a simulation. All right, so according to the simulation, it takes on average, let's see, 11.67 batteries to get 10 working ones. All right, so on average, they need to pool almost 12 batteries to ensure 10 working ones. All right, let me go ahead and show one more example, and then your homework will be the third example. All right, let's go to quiz B. Okay, this one says, on January 1st of every year, many people watch the Rose Parade on television. The week before, the parade is very busy for float builders and decorators. Roses, carnations, and other flowers are purchased from around the world to decorate the floats. Based on past experience, one float decorator found that 10% of bundles of roses delivered will not open in time for the parade. 20% of the bundles of roses delivered will have bugs on them and be unusable. 60% of the bundles of roses will turn out to be beautiful, and the rest of the roses will be delivered, or of roses delivered, will bloom too early and start to discolor before January 1st. Conduct a simulation to estimate how many roses the float decorator will need to purchase to have 15 good bundles of roses to place on the float. All right, let's go ahead and start with our acronym. And we have starting with assign. All right, so to kind of simplify this, we don't really need to know if the roses aren't good because they bloom too early or too late or because of bugs. I'm just gonna say good versus bad because that's all that kind of matters at the end. So it looks like 60% of the time the bundles will be good And 40% of the times, the bundles will be bad. All right, so I'm going to assign 0 to 5 to represent good roses. And I'm going to assign 6 to 9 to represent bad roses. All right. And the reason why I go from 0 to 5 to represent 60% of good roses is because that actually is 6 digits, right? If you count 0, 1, 2, 3, 4, 5, that's actually 6 digits. So that's 60%. And then the bad, you have 6, 7, 8, 9. Those are 4 digits to represent bad digits. So you can even list them out if it's a little easier for you. And you can see that there's 4 digits there. Okay. All right, or you can just do 6 to 9, and that's good too. All right. So from there, we want to say picking. So we are picking 1 digit at a time. And we're going to stop once 15 good roses are picked. And at the end, we want to count how many bundles it took to get 15 good ones. Okay, so that is our simulation. All right, let's go ahead and try it out on our random digit table. All right, so starting with 3, I have a good rose right there. All right, this one is bad. That's a 7. 5 is good. 4 is good. 2 is good. 0 is good. 4 is good. 8 is bad. 0 is good. 5 is good. 6 is bad. 4 is good. 8 is bad. 9 is bad. 4 is good. 7 is bad. 11, oh, excuse me, 4 is good, giving our 11th bundle. Then we have another good one. We got a bad one, got a bad one, got a good one, got a good one, got a bad one, finally got a good one. All right, and that is 15. I'm gonna stop my trial right there. All right, so that is, let's see, 5, 10, 15, 20, 24. All right, so it took us 24 bundles to get 15 good ones. All right, let's jump to the next line for our second trial. We want to do 3 trials here. Okay, so this one is good, bad, good, 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 bad, 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 good, 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 bad, bad, good, 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 bad, good, 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 and good. All right, so I stopped my trial right there. Okay, so that time it took me 22 bundles to get 15 good bundles. Okay, let's do that one more time. And oh, we start with a bad one and another bad one. Then we get some good ones, another bad one. Good, 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 bad, good, bad, good, bad, 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 good, bad, good, 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 bad, good, good, good. All right. So that time it took 25 bundles to get 15 good ones. Okay, so we did our 3 trials, and let's go ahead and state our conclusion. I'll just go ahead and type it down here. All right, so conclusion for number 3 would be, according to the simulation, all right, and I think an average would be a good number to give here. On average, it took, and let's go ahead and average out those numbers. So 24 plus 22 plus 25 divided by 3 gets me 23.7. All right, so it took 23.7 bundles to get 15 good bundles of roses. All right, and that would be my final conclusion for that simulation. Okay, so for homework, I want you guys to go ahead and try this last question about Billy and his chickens. So give it a shot, and then we'll go over it in class tomorrow.